Hello, this is Keith Kreischer, the Executive Director of the IoT M10 Council, or IMC. And it's my pleasure to welcome you all to this webinar on 5G and the Edge in Industrial Applications, brought to you by the IMC. I certainly hope everyone joining us today is staying safe and well in these interesting times. As I said, today, the topic for today's discussion is 5G and the Edge, and it's going to be moderated by my good friend Robin Duke-Woolley, founder and principal at Beecham Research, one of the best-known analyst firms in the IoT sector. And the panel will feature folks from KYOCERA AVX, Tata Communications, and floLive for the next hour or so. I'm going to hand off to Robin in just a minute, but first, before we begin, I wanted to cover just a few housekeeping items. This webcast is being streamed through your computer, so there is no dial-in number. For the best audio quality, please make sure your computer speakers or headset are turned on and the volume is up so you can hear the presenters. An on-demand version of the webcast will be made available later today and can be accessed using the same audience link sent to you earlier. If you have any questions during the webcast, you can submit them through the Q&A box on the right side of your screen. The presenters may answer questions at the end of their presentations, but please feel free to ask questions at any time during the slides or the following discussion. Any unanswered questions will be responded to offline if necessary. And I want to emphasize that we do have a record of your registration, and we can associate that with your question. So, any and all questions will be answered if necessary after the session today. For those of you that do not know the IMC, perhaps just a quick word of introduction. The IMC is the largest trade organization dedicated to the global IoT sector. Its membership is comprised of 28,000 individual rank and file adopter members who are enterprise users, product makers and OEMs, and apps developers that actually deploy IoT solutions. The IMC's board of governors includes 35 of the most influential IoT technology companies that are providing solutions in the form of hardware, software, and connectivity. We encourage any attending today to check out our website, iotm2mcouncil.org. On that website, you'll find information about the IMC's newest initiative, just recently announced publicly, and that is a joint task force on IoT security formed with the Global Certification Forum. There's lots going on in the area of IoT security right now, but what makes that initiative, our initiative, so unique is that it covers not just devices, but also networks and cloud app platforms. So please look for that on the website. Moving along to today's session, the mission of the IMC is to accelerate the adoption of IoT technology for the public good. And we look at today's panel discussion on 5G supporting edge applications in industrial usage as something that's exactly in keeping with that mission. So now it's my pleasure to introduce Robin Duke-Woolley from Beecham Research. Robin, good morning or afternoon, as it were.
Thanks very much, Keith. Yes, good to be here. So welcome to everybody. And I'd also like to introduce the speakers today, speakers and panelists today. Rony Cohen, who's co-founder and head of strategy and business development at floLive. Sadanandan, who is AVP and head of product for private 5G, Tata Communications. And then Carmen Redondo, who is Director Global Marketing Antennas at KYOCERA AVX. As you can see from their titles, they have a very different interest in this topic of 5G and edge. So I think Rony will be coming at it more from a public network perspective, whereas Sada will be coming at it more from a private network perspective. And then Carmen is looking at it from an antenna perspective for both. So sort of brings them together, really. So quite an interesting and diverse set of panelists for our discussion. We're going to start with some very short presentations just to introduce you to each of the panelists and also what they do and where they come from. And then we'll get into a discussion. Do please send your questions in. We'll be aiming to get to those during the discussion. And we hope to answer as many as possible. As Keith mentioned, any that we don't manage to answer, then the panelists will have those afterwards so they can follow up independently. So your questions will be answered. So it'd be very good to have them and start things off. Okay, so I'm going to introduce a few slides really to start this process off. And the first one is really, what is edge? So there's a user edge, there's a service provider edge, there is a centralized data centers and so forth. There's quite a lot of different definitions of what edge is. I think the most used terms are like constrained edge, which is also known as thin edge. There's on-premise data center, which is also known as thick edge. So a thin edge has relatively small amount of processing. On-premise data center, of course, has lots of processing. Then there's near edge, refers to near the telco's central offices, so very close to the central offices. And far edge relates to the edge of the telco network, so cell towers and so forth. And there is a reason for all of these distinctions. But basically, the interest is moving the processing as close to the application as possible, and thereby reducing latency. And we're going to be talking about that and what that means in the next in the discussion. So the next point then is we do surveys all the time in this marketplace. And one of the questions that we asked is, why do we want IoT at the edge? And some of the responses came back really relating to this slide. And I think it's interesting that security compliance came out top, along with operational efficiency, and then obviously others as well. So application performance with 35%, customer experience, improving the customer experience, 33%, productivity through automation, 31%, and faster and better decisions, 28%. Obviously, those will vary for different companies, but it gets an idea that there are a variety of different reasons for implementing edge, and there are some strong expectations about what it will provide in terms of benefits. Another one, just to sort of illustrate that a little bit more, if you can see the writing, it's a little small, but we conduct one-on-one interviews all the time as well, and we ask questions about IoT edge drivers and trends. And I've highlighted three here just to sort of provide a sample, if you like, of what people are saying in the marketplace. So the first one is, do you really want to stream that data to the cloud? Because there is a cost there. If you could process all that data locally and only stream the valuable data, that would reduce costs. But I think the biggest driver that we see is security. So that reinforces the first survey results that I mentioned just now. And then the most prevalent trend is in reducing latencies. I'm finding it difficult to read it myself. It's quite small writing. You reduce your latency just by having computing and data physically closer to the user. And then the third one is more about industrial applications and how those are driving use of edge quite substantially. So there are three quotes just to sort of give an idea of what people are saying in the marketplace. Now, I'm going to hand over to Rony shortly, but before I do, I just wanted to introduce to you a new report that actually is being launched today. It's a free report, and it's about IoT security. So security obviously is a very important aspect of edge, as I've just mentioned. This report is called Locking in Value with IoT Security, Building Trust, Protecting Profits. This actually is done or has been done in association with the IMC. You can see the handouts for this, or you can see more details about this in the handout. And it's a free report, and it's available at www.beechamresearch.com/IoT-security. So do have a read. I think you'll find it quite interesting. Right, well, I'm now going to hand over to Rony Cohen, who's going to introduce us to floLive and what floLive does as a prelude to the discussion points that I'll be putting to him later. So over to you, Rony.
Thank you very much, Robin, and pleasure to be here again with the panel and with the IMC. So I'll give a little background about floLive, just generally about myself. I've been in the mobile space for just about 20 years now, and floLive is really the everything that we ever wanted for the IoT space when I was involved in mobile operators before that. And that was basically building the world's largest infrastructure for IoT, the world's largest infrastructure in core network terms. So floLive has a distributed network around the world, which I'll get to in a minute. But the idea is really to provide that coverage, that availability, but also from sort of a single policy that you can rely on when you've got a device that needs to connect to the end to the internet. And our customers really are the service providers, the mobile operators, where we provide our infrastructure for them as well, and our management platform, but also large enterprise customers as well who have a need for their own network. About 170 people, and we're pretty much a global company. I will slide over to the network side of it, which really is gives a bit of a flavor. So really, this is an infrastructure company with 70 packet gateways across the world, with over 40 core networks. Pretty much everywhere in the world, we could provide the cellular infrastructure with partnerships with over 20 mobile networks. Most of them are our customers as well. So they're using our infrastructure in their own country, but they're providing us with that access to their regional footprints, global footprints. On top of that network, on top of that infrastructure network of core and packet gateways, which is extremely important, obviously, for 5G, which is the topic of today, we have a layer, software layers of real-time billing, and I'll skip the SIM management for a second, but connectivity management platform and real-time billing platform. Meaning when we're running our own packet gateways around the world, we really have a real-time, and what some industry analysts called it, real time, and it's not near real time, because we're sitting on the tap and we can control it. So you've got the first application layer of real-time billing and a connectivity management platform, which truly allows you to enhance and create policies across the network, which you can actually rely on. In most cases, when we're roaming, when we're using remote networks on the mobile operator side, it's very difficult for the large enterprise customers to enforce a policy, or even the MNOs to enforce a policy on someone else's network. So that's really that. The SIM application management is really our ability to provide multiple IMSIs in various EUICC or an eSIM form, multiple IMSIs, and switch between them with our own apps on the SIM itself. The slide is slightly lacking. I apologize for that, because it's sort of an animation, but it didn't come through in this. So I'll explain it a little bit, but it kind of gives the importance of what local IMSI with local infrastructure is compared to a roaming SIM. Really what we're looking at I'll give the general numbers. We're usually looking at 40 to 50 milliseconds on local SIMs compared to 120 and above, especially when the roaming SIMs are in various places. So, for example, a US carrier roaming in Asia would reach sometimes 300 milliseconds, 250 to 400, I'd say. That's the sort of the average, whereas a local SIM would reach 70, but anything under sort of 80 would be acceptable for some of the applications. But from reliability point of view, you're really looking at a low latency of 50 milliseconds and below. That's what we're looking at for edge applications. So that's sort of a little bit of a background about our infrastructure, about why the partnerships with the mobile operators are so key, and about our layers of application on top of the infrastructure. And we continue to develop that for the benefit of our customers to manage their devices more efficiently across the world. Robin, I think I sort of don't want to take any more time. I hope that's clear.
Yes, no, that's fine. That's great. Yeah, super. Thanks very much, Rony. Okay, we're now going to hand over to Sada Kala at Tata Communications. So he takes a more interesting view of private networking. So over to you, Sada.
Thank you, Robin. Yeah, so it is very happy to be here in this webinar. So let me give you a brief about me. My name is Sadanandan. So I am heading the network and application engineering for the IoT and private network solutions business for Tata Communication. So about Tata Communication, basically we are a ComTech player in the industry where we power the enterprise customers hyper-connected ecosystems with our digital fabric solutions. So when we say digital fabric solution, it is basically a kind of a collection of multiple products and platforms and tools. So we have products in different technology areas like networking, where we have the products on the MPLS and SD-WAN, Wi-Fi, products, and then also we have other products like cloud products, edge cloud, and then AI cloud products, and then also the IoT solutions, and then private network products. So there are multiple products we offer to customers, and then platforms and tools put together. We provide digital fabric to our customers, and basically it's a solution-oriented approach along with proven managed services, collaboration, security, IoT, cloud and mobility. So the entire solution together, we provide a digital fabric solution to our customers. So moving on to the next slide. So basically, we are. If you look at the Tata Communication, which is part of Tata Group of companies, and Tata Communication is a 2.4 billion company with 12,000 plus people, and then we have around 7,000 plus customers. We are providing our products and solutions to 7,000 plus customers. So I wanted to focus here on the digital IoT fabric, basically. So when we say IoT fabric is is again a collection of multiple products and then platforms and and then applications, basically. So see, basically the IoT fabric is a multi-layered solution. It provides connectivity layer, platform, and the AI-based analytics solution, and then many applications for the different use cases to be enabled. So that is basically the IoT fabric. And then looking at the connectivity layer, so we are providing different technology connectivity layers. So like the LoRaWAN, the low power and long distance WAN based IoT solutions we provide. And private network is another product we offer for the industry 4.0 transformation. Then also we provide the satellite-based IoT solutions, public cellular-based IoT solutions, and then also the managed Wi-Fi. So these are the different connectivity layer we offer part of our IoT fabric. And then the different platforms, we also provide different platforms. One of the platform is we call it as Move platform, which is basically providing the the connectivity globally to the different IoT applications like connected cars and then the connected devices. So different IoT solutions we provide the connectivity globally by making a kind of an agreement with many MNOs, 200 plus MNOs across the globe. We have the agreement, and then we provide the Move platform. And then IoT platform is another solution. LoRa-based IoT platform is another platform we offer to our customers for different type of IoT use cases like connected workers and then street light controllers, smart city solutions, and then also smart parking. All these different types of applications we provide to multiple customers through our IoT platform. Then video analytics is another platform we offer to our customers. Using video analytics, we can provide different types of use cases like intrusion detection, geofencing, surveillance, quality inspection, different types of the use cases we can offer through our video analytics platform. And then also we have the platform which can be used for the utilities like smart metering, smart gas meter, smart electric metering, smart gas metering, and then and also the smart water metering. This kind of applications also we have a platform, the utility platform, and then also we are providing the eSIM and SIM management platform to provide a solution to our end customers. So then we also have developed a digital device management platform, which is basically to manage the devices, its software upgrades, and also getting the status of each and every devices. So we have the device management platform, which is being used for both IoT and private network-based devices. We provide, and then also we have a service orchestration platform, which will provide the configuration management, port management, and performance management kind of solution for supporting our operations. So we for our managed services, we have a service orchestration platform which will give a kind of a very high customer the experience, very good customer experience using this platform we provide. On the analytics, we have AI-based video analytics platform, which provides different use cases like surveillance, quality inspection, inventory management, and also we have the network analytics along with this analytics solution. So the different applications we provide is one is connected worker. Using connected worker, we offer multiple our customers kind of safe passes, and then different wearables like watches and then helmets, etc. We provide to our customers as a connected worker solution we provide. Then we also provide smart city and smart parking kind of solutions, and also the video the various video applications like face detection, intrusion detection, inventory management, those kind of solution we offer. So that is a kind of a quick summary about the IoT fabric we offers to our customers, and basically it is a multi-layered solution. So by providing this, we ensure that we provide a very high secured kind of solution with very lowest time to market kind of solution we provide to our customers. So that is a brief introduction about Tata Communication and IoT Fabric. So back to you, Robin.
Thanks very much, Sada. Now swiftly on to Carmen Redondo, who is from KYOCERA AVX. So over to you, Carmen.
Thank you, Robin. Hello, everyone. So my name is, as Robin said, Carmen Redondo. I'm Director of Global Marketing for Antennas. I have technical background. I have more than 15 years experience in antennas. I've been doing the antennas myself. I've been working many years as an antenna engineer. And today we're going to talk about 5G. So let's start first about introducing KYOCERA IBX. So we are the a leader manufacturer of advanced electronic components. We cover many different types of components, from capacitors, connectors, sensors, crystals, and one of them is antennas, which is the one I'm in charge of. Our company has a headquarters in the US, in South Carolina. However, we are under the umbrella of KYOCERA, which is a Japanese company. We have factories and design centers worldwide for antennas. Our design centers, where we have all the equipment for prototyping and testing for supporting customers locally, are located in San Diego, France, in Nice, in the south of France. We are in Taiwan, China, and South Korea. And then our factories are located in China, South Korea, and in Vietnam. So we are able to diversify the production locations. We cover different markets, from automotive to medical, industrial, and then, of course, the IoT, which is covering many different types of applications. So before we start in the second part in the panel, when we start talking about more details about antennas and how the different types we have or we can support with, I would like to first remind everyone, what we mean with 5G, because 5G is a word that involves many different meanings depending on the technology that has been used. So probably many of you are familiar with this type of triangle to represent 5G. So we have the enhanced mobile broadband, which is a kind of the beginning of the 5G, where we wanted to increase the capacity, have bigger, higher speeds, more broadband. And this is the type of the origin of the 5G application. But later they have also been focusing on the low latency for like applications like mission critical communications, where you want to have like real communication in real time and high precision. So this is another type which is it has some differences from the hardware and antenna point of view compared to the previous version or the previous site. And then we have what we call is commonly used or commonly called IoT, where we are in massive deployment of devices with very efficient power consumption. So you are able to have devices in the field for several years. Now there is another concept that has appeared recently. It's in the last times which is RedCap, which stands for reduced capabilities. And this, let's say that is kind of the trade-off between the 3 points of the 3 vertices of the triangle, where you still can have more speed than the IoT, but at the same time you can also have a cost-efficient solution because it's not such a complex electronics or configurations compared to the others, and also you can benefit from the power-saving conditions like from the IoT. So this is, let's say, the kind of scenarios that we have, where we are talking about the industrial IoT, which is the topic of today. Normally, the most common ones used will be the RedCap of the IoT, which can cover the LTM or NB-IoT, for example. But then we will enter more in details about different antenna types and the considerations to have into account in the panel. That's it, Robin.
That's great. Thank you very much, Carmen. That's super. So now we're going to move on to the discussion with all of the panelists. So Rony, I'm going to start with you because I want to sneak in a sort of 2 questions at you at once. So because I think it helps to sort of set the scene a bit. So the first one is, how does low latency benefit edge devices? And the second one is, what network strategies are employed to achieve low latency? I'm hoping that you can get into both of those. I'll repeat them if you like.
No, it's fine. I think starting from the second part of the question, because it'll sort of answer the benefits. I think floLive is a unique company in the sense that it really has built its own infrastructure, and against all odds, it's got an infrastructure in pretty much most places in the world where we have customers, and in every continent. So in that sense, it's quite a unique story, because there is no really a second company like that in terms of the network. Now, when you say about what strategies, it basically means setting up a core network and a local partner or more in each country, and I think that's the strategy.
Okay.
In essence, it's not something that's easily replicable. In terms of what are the benefits, obviously the low latency ensures near instantaneous communications between a device and the network, and that's really affects the decision making of the device. Because if you've got low latency, you're dealing with bad decisions and the real-time processing. If you talk about what Sada was talking about, autonomous driving, really requires immediate feedback. When we talk about sort of autonomous driving vehicles, or even regular vehicles that are downloading ADAS systems, etc., but they're outside of a private network environment. It's all good in industrial applications, but when you're driving across the road and your car is downloading 5-kilometer square carpets of ADAS related information, you really don't have time for 300 milliseconds or 200 milliseconds response time. So that's sort of an example about that. And you're really improving your accuracy when you have low performance. The other thing is, if you're looking at sort of cameras, video conferencing, things like that, things that are in the field, face recognition cameras, again, these are all things that need relatively quick download of user information data. And there's no edge device without a cloud, right? So that response needs to go back and forth. Packet loss and jitter are very crucial for, at the end of it, for security. When you've got packet loss, you've got packet loss and jitter, you're struggling with security. It's a vulnerability. Now, we can't say anything without saying AI now, but we can't finish a sentence without saying AI in it. But AI-driven edge devices use predictive maintenance systems, require real-time interfacing. So low latency really helps ensure rapid model execution and timely insights. I think sort of that gives when you talk about, you spoke about security as well. So the real-time, preventing data breach.
We'll come back to that. I think we don't want to get into too many things at once. So that's a really good starting point, though, as to why Edge is useful and how to implement Edge. So I'd then like to move on to Sada and talk about the private network element of it. So what are real-world applications for private 5G and edge computing? And how do we demonstrate the tangible benefits of these use case applications?
Yes, thanks, Robin. So there are many use cases we can provide using the private network, along with the MEC and the edge computing. So one of the use case is the video analytics based quality inspection. So see, when we talk about quality inspection of any product, like the finished product, like a PCB manufacturing in the electronic industry, or in a car manufacturing plant, the paint quality inspection, if it is done manually, there could be a lot of errors which can happen, human errors, and then due to the poor, cost of poor quality, it will be much higher if there is a quality issues happen in the finished product. So now all the manufacturing plants, car manufacturing and other manufacturing industry wanted to automate the quality inspection. So how they do is the high definition video will be taken of will be streamed. Of a finished product, it will be streamed to an application which is running in the Mac. So usually it will be an AI-based application running in the Mac, and then the video which is sent to the application, it will compare with the reference image and then ensure that compare and then detect if there's any defect in the finished product. So by the private network with because basically the video streaming will need high throughput, high bandwidth. So the private network will provide the high bandwidth, and then the Mac will provide the immediate quick comparison of the product image versus the reference image, and then it will produce the decision on the quality, the product quality, immediately. So that is one of the applications. So similarly, there are many applications like for the safety, intrusion detection. If in a mining area, mining and oil rigs, etc. The people going into some areas may be hazardous. So if somebody goes to an area which is hazardous, if the video analytics can detect that, it can send some alarms and then ensure that the person can be taken back to to the safety. So that kind of applications. AGV is another for material transportation. So previously, all these plants were using different communication technologies, but then the reliability was poor. So now with 5G, they are able to make a very highly reliable type of communications, and then the AGV use case they are able to make it. And another one is the drone-based inspection. So in big oil rigs and all, the drone-based inspection is also can save a lot of time, because if it is done manually, the plant shut down, and all those can be reduced by quickly doing the drone-based inspection. So like that, there are many applications like asset tracking, mission critical push to talk. All these applications, all use cases can be enabled using the private network.
That's super. Yeah, that's terrific. Thanks very much. Moving on to Carmen. So you presented earlier, Carmen, the triangle of different requirements, if you like. So 5G means different things, obviously, depending on the technology, whether it's 5G new radio or 5G RedCap, as you mentioned, or low power options like NB-IoT and LTM. So what are the key antenna requirements for each of those, and how do they differ? What's your secret sauce?
So yeah, it's very different, right? So that's why when the customer says, "Oh, we need 5G antenna," okay, but 5G, what do you mean by 5G? How they're gonna use it, etc. They mention a lot of different applications, and depending the application you want, you will need some certain kind of technology, let's say. So we start, for example, with the original 5G, as I said, the high speed, more bandwidth. So the biggest difference compared to the predecessor, which was 4G, is that in this case you are having MIMO in antennas. So before, with 4G, you could have maybe 2 antennas, one use a diversity. Now you're having a pure MIMO. So it's not only using 4 antennas most of the times, but also those 4 antennas, they also transmit all at the same time. So all this can affect not only for the performance between them, right? You need to have very good isolation between them, etc. But also requirements like SAR. If you have devices which are close to the body, then those SAR requirements, when you are transmitting, more antenna transmitting, is more difficult to control those. We are doing a standard or custom antennas. So, of course, in the custom, you have more flexibility to solve these challenges. You also have external antennas in a standard. But if we are talking about embedded antennas, no, because this is even if you have a standard, once you integrate antennas inside the devices, that's when the complexity comes. So in this kind of configurations, we have 4 antennas. We have created some antennas with the off-board, so you can connect directly to the module. Many times they come with the receptacles in the M2 cars, M.2 cars. In this case, we have created some antennas where they are 2 of them are covering all the bands, and the other 2 are covering only the high bands. So normally, many of the 5G modules in the market, they are only having MIMO in the higher bands. So that way, you are able to integrate it, improving the isolation between them. So that's an example. Now, if you go to the other extreme, where you go into the NB-IoT, I think this is it's only 1 antenna. So in that case, it's kind of simple, but of course we come with all the considerations about the size of the device, how the PCB length affects on the performance, etc. When you come into the red cap, there you can have 1 or 2 antennas similar to for the low latency application. So there it also depends, and also the frequencies. When you are looking into the low latency, normally you are using the middle bands around 2.5, 2.6, 3.5 gigahertz. So there it gives you maybe a bit more flexibility to integrate antennas in terms of isolation and make it a whole MIMO system. But yeah, so it's even different frequencies. NB-IoT is more like the sub-6 gigahertz. The low latency is more in the mid band, the C band. So as you can see, it's different kind of consideration. So it's very different when you are talking about different, LTM or red cap or the new radio.
Yeah. Yeah, so it's a wide variation, and you have to design the antennas accordingly. Yeah.
So we are trying to have quite a broad portfolio, not only of embedded but also of external antennas to support these kind of configurations. But we also go in situations where you really need to also do custom design, so we can help the customer in all these ways. And of course, with the validation, because later you need to do measurements like TRP, TIS. With the whole module plus antenna to make sure that you meet the requirements of the network.
Yeah, that's great. Super. So, Rony, I wanted to move on to the security issue with you that we touched on very briefly earlier on. So, how can organizations address security and privacy challenges in distributed edge computing within industrial 5G applications?
I think the main method that we are addressing security in the mere fact that we can provide a single point of management and policy across the whole network. I think it's, I know it sounds like we're stating the obvious, but at the end of the day, when you've received a SIM from one carrier and you're roaming on another carrier, there is very little influence for the original carrier to provide you the policies that you wanted on someone else's network. They have no capability to say to the network, we need priority, we need you to do this or over that, or, force a RAT type, etc. But it's very difficult. And in that respect, I think that is the main security policy that we could provide. There are various layers and VPNs, etc., that we could provide, and all sorts of network security and anomaly detection that we run and in AI on the network, etc. But at the heart of it, it really is managing a network that you can control as opposed to hoping for the best. And with regards to privacy, again, it sort of comes down to the same thing, because usually you need to drop the data or not cross-border the data. That's GDPR. It depends. Every subsector, financial services has it, transportation has it, the car industry has it, various rules and regulations, which mean that you need to maintain the data or the connectivity within the country. There's some elements of the data that you cannot move outside across border, outside the European Union or within the US, etc. So having that local network allows us to drop the data unterminated with local IP addresses. For example, some government, ambulance services, for example, would want all 4 networks in the UK, but with a local IP address. And that's sort of an example that I can give it, but it wouldn't work with 4 networks with coming in from a foreign internet connection. So all that regulation requires local network, and I think we answer it in the same way.
Okay, all right, no, that's great. So I wanted to come back to you, Sada, and talk a bit more about private networking. So there have been some delays in adoption of private networking. So what would you say are the typical challenges of private 5G and edge deployment that is delaying adoption of private networking and edge computing for IoT? What would you say the main issues are?
So let me explain. There are few challenges. So one of the major challenges is the spectrum. For the private network is basically kind of cellular technology. So it needs the spectrum, and then in most of the countries, spectrums are regulated. So but in certain countries like USA, Germany, UK, and then some of the European countries, they have the dedicated spectrum for private network. In those countries, the private network deployments are not taking place at a faster pace. But whereas in many countries, the spectrum is not dedicated spectrum is not available for private network deployment. So in those countries, the enterprise have to depend on the MNOs who have the spectrum. So they have to depend on these MNOs to deploy the private network. And then some countries they are deciding on dedicated spectrum for private network deployment. So that is one challenge which enterprises are facing to deploy private network. So what they are doing currently, they are doing trials and POCs, but then because of the spectrum availability, they are delaying the deployment. And then another major challenge is the technical expertise, because most of the enterprise may not have the telecom expertise with them. So and then because of that, the adoption is getting delayed. So and then also integration with the existing IT/OT network. The integration of private network with IT/OT network also will be a challenge, because if you have to have a common management and orchestration for managing the network, so integrating the private network with the existing IT/OT is also getting some challenges. So, but then it is evolving. So, but these are some challenges, and the cost initial investment for the private network is much higher than the other technologies like Wi-Fi and the other technologies. So that is another challenge we are facing. And then also the device readiness. So most of the devices, the end devices like video cameras and sensors, PLCs, all these end devices, it is not 5G enabled. It will have either the Ethernet communication or Wi-Fi connectivity. So since these end devices are not having the 5G modem within that, so directly communicating the 5G network would be a challenge. So what we have to do is we have to provide a CPE device in between which can support the 5G. So that is how currently we are deploying the many use cases. We have to put a CPE device in between. So that is another challenge we are facing. So like that, there are multiple challenges currently we are facing, but then it will definitely getting resolved over a period of time. So now coming years onwards, the adoption is much faster. So that's what we are expecting.
Yeah.
So that is
okay. That's great, because it's taken a while for private networking to take off. But I think you've explained some of the challenges and what's going on to address that. So that's great. Thanks very much, Carmen. Can you share one or two examples of IIoT applications and how KYOCERA AVX supported the antenna design to meet the specific connectivity needs?
So, yeah, I mean, I have examples also when having integrated several antennas, you know, and MIMO. But since we are short on time, I will focus on one that I think is very typical. So we always tell our customers, you know, when you're designing a device who has an antenna integrated, it's very important to reach or decide what antennas will be before you start doing the dimensions, etc. Right? So we have a customer who was integrating a design. In this case, was for the low power, so it's only one antenna in this case. But they designed everything with the antenna in, let's say, in the wrong position. So it was not our antenna, in fact, it was not something else. And they placed the antenna, you know, normally you want to see the length to have the low frequencies radiate better, but they put it on the side. And they were really desperate in this kind of sensor for industrial application. And they asked us for help. So we really help in the, let's say, in the worst conditions to be able to bring their device to life. So basically we make a design based on a standard antenna, but customized for this critical condition to be able to cover the bands. It was a device was going to be worldwide. And then we'd find a way to find different SKUs to be able to see that, to meet all the certifications. And then finally they managed to bring their device into the different countries. But yeah, this is an example of how we are helping. This is putting from the worst case, like coming in the wrong condition with something else that was with our control, everything frozen. But from there, we have been able to help them to bring into that. Not always is possible because we cannot do magic. So that's why it's very important to have this into consideration. But this is one of the examples. So.
Yeah, that's great. Okay. I mean, there is a question for you, actually. Antenna plays an important role in getting higher throughput. So my question is, this is from Ravinda, regarding higher order MIMO in RedCap, how can we embed more antenna elements? I'm sure that makes sense to you. I'm afraid it doesn't to me.
Yeah. So, well, I don't know exactly what you mean by how, but it's more by adding more antennas, right? So in the end, it's saying that you have one single antenna, you will have to implement two. So normally you want to have into consideration the way about the isolation between the frequencies, especially when you are ordering, you know, in lower end sub-gigahertz. The lower the frequency, the more difficult it will be to keep the isolation between the antennas, right? So it all depends how big the device it is. And you also want to have, maybe sometimes super and perpendicular, or you will say, I mean, what is the ideal condition to have the better, let's say, MIMO system? So this is some measurements that we can do. But the rule of thumb, it depends of the size of the device and where we can place the antennas. But yeah, it's just by adding more antennas. So
Okay.
that's if it's how.
Adding more. Yeah. All right. That's right. So the next question is, I think it's primarily for Sada, but I think maybe Rony might be interested in it as well. So how does public IP network compare with a private IoT network in terms of costs and benefits for a government organization? So Sada, perhaps you could start with that one. But Rony, you might like to comment on that as well, perhaps? But anyway, let's start with Sada. You can think about it.
Yeah. So basically the question is the comparison of the public network and
Yes.
then the private network
And the costs and the benefits.
So basically,
for a government organization, yeah.
Okay. So see, public network, basically the public network provides it doesn't provide the dedicated coverage for a specific government, campus or other campuses. So then whatever the bandwidth throughput it is coming, and then latency, so which is offered by the public network, may not be suitable for all the use cases which is required in an organization. So if there is in a government organization, if they have to implement some video based analytics solution for some intrusion detection or surveillance purpose. That may not be possible with a public network. So they have to implement a private network. And then the cost, but definitely the cost for implementing the private network when compared to the public network will be more, because the public network, it will be SIM-based charging, right? So but then in the private network, there is a implementation cost involved, so it will be much it will be higher. But then the use case which we can implement using that will be a much more, much more than we can do using the private network rather than public network. So basically, that is a difference.
Okay. So Rony, I don't know if you've got anything to say. I can repeat the question if you like. Or
no. I mean, I think it doesn't matter for me as if it's a government organization or not in terms of the use case. I was trying to think about it. I think the it comes down to the need. I don't, it's a campus-based environment with needs very, very low latency. Then there's a need for a private network or a factory or something like that. Apart from that, we have various use cases of private and public handover. So you can have a private network in a factory or a site or a campus, and then when you're outside of that factory, that same device still needs connectivity and does a seamless handover to our network. We've partnered with local, antenna manufacturers, etc. But basically, we've built a small core network on site in order to deal with it. And then a local antenna provider, who works with us on the local site, for the local RAN. I think it's obviously more costly to build a private network, and but there are benefits. Are very, you can get to very low
latencies.
On the actual site.
All right.
It's a much more costly situation. Scenario.
So there's a sort of follow-on question here to security, which I don't know whether, not quite sure what he's getting at actually. So do you believe in forcing strong authentication or relying on others? I don't know quite what that means, to be honest. I don't know if anybody can help with that. Do you believe in forcing strong authentication or relying on others? So in other words, doing strong authentication yourself or relying on others in the network to do that?
It depends which network you're relying on. It depends, not every network is built the same, and not every provider can force a scenario in someone else's network, as we suggested. So I would say, try and force your own rules and regulations on your policy across your network, across the network that you wish. And see what you're providing, challenge the provider that's providing you the infrastructure or the network to see what sort of level of security that they're willing to provide to you.
Okay. It's a slightly awkward question, to be honest. There's one here for Sada, which is how do you manage security for your 5G IoT fabric?
Yeah, so we have a multi-layered security in our private network product. So which is starting from the end devices to the network level security, and then also a perimeter security, which we provide a perimeter security, on the N6 interface, where it is going to the applications. It could be the application may be running in the MEC or in the public network. So we need to provide a security layer at the at the perimeter, and also we provide the security at API layers. So these are the different layers where we have to ensure that security is provided. So it's a multi-layered security we provide in our private network product.
That's great. Okay. Well, that's the end of the session, actually. We need to close it there. So I'd like to thank our panelists for responding to the various questions, and also for your short presentations, and also to the audience for sending in your questions. So I'll now hand back to David, who's going to take you through some other announcements.
Thank you, Robin, and thank you to all of our audience here. Please join us for our next online event, which will be in April. On IoT Days Spring, we'll be discussing low power and how that can benefit the IoT development as well. So we thank you all, and join us next time.
Thank you very much.
Thank
Thank
you.
you.
Okay, thanks.
Bye.
All right.
Thanks
Bye
for
now.
everything.